Man's quest to ascend like a bird from the surface of the earth began as a dream, and for thousands of years was nothing more than that. Around 400 BC, man had taken the first step toward turning his elusive dream of vertical flight into reality in the form of toys. Toys that at the pull of a string or twist of the fingers would climb into the air on spinning wings, the first man-made object of any kind to fly under its own power. In the 14th century, in his now famous drawing of the lifting air screw, Leonardo da Vinci wrote, "I find that if this instrument with a screw be well made and be turned swiftly, the said screw will make it spiral in the air and it will raise high." This was the world's first proposal for a full-size rotary wing device. In the following centuries, several model helicopters were built and flown, but none to any degree of real success. But in 1784, flying mechanical models made by the Frenchman Linné proved rotary wing flight was possible. In the late 1800s, on the other side of the aviation fence were the fixed-wing pioneers, who were also having their share of trials and tribulations. It seemed like everyone shared the same degree of success in their early attempts to free themselves from gravity. But man, in his steadfast persistence, finally did manage to get his fixed-wing machines off the ground. The helicopter pioneers, on the other hand, had a very, very long way to go. As the 20th century began, technology had progressed far enough to supply the inventors with power plants capable of producing some lift. Unfortunately, though, not enough to lift the weight of their machines. It seemed the only thing holding back the development of the helicopter was the lack of a suitable engine. But when suitable engines had been produced, these aviators soon realized that an engine was only one of a multitude of problems they would have to overcome. In the decades to follow, each one of these problems had to be identified and resolved by countless engineers throughout the world. In 1907, the history of the helicopter really began with the first free flight of Kornu's helicopter. Igor Sikorsky followed, along with numerous others, most managing to get off the ground with little or no control once they were airborne. (1927) was the year Charles Lindbergh made the first transatlantic flight. By 1930, the world record for helicopter distance was 1,200 yards. The first transatlantic helicopter flight would come some 37 years later in 1962. The year 1940 saw Igor Sikorsky make great strides in controllable direct lift flight. In that year, he set a world endurance record of 1 hour and 32 minutes. In the United States, World War II brought intense government interest in the helicopter. Government funding and military contracts followed. This was the real birth of the helicopter industry in the United States. By the end of World War II, with a complete shutdown on helicopter research in the USSR, Great Britain, and France, and with the annihilation of German industry, the United States found itself the leader in helicopter research and production. The 1950s brought the Korean War and a new role for the helicopter, providing medical transport to mass units. By the late 50s, a powerful new breed of helicopters was born that sparked a revolution. Jet engines weighing one-half that of their piston-powered forerunners produced even more horsepower and were small enough to mount on top of the helicopter, making for a roomier cabin. The 60s and 70s saw the most dramatic improvements in safety, dependability, and efficiency. Proven in the Vietnam War, the quality of the helicopter rose to astounding heights. Unfortunately, so did the cost of these machines, not to mention the cost of maintaining them. The 80s have and will continue to see monumental breakthroughs in helicopter design. Here are some present-day helicopters and their prices. You'll see by these astronomical price tags that the helicopter industry has totally forgotten the private individual. Can you afford any of these machines? Unfortunately, the only people capable of experiencing the freedom and excitement the helicopter has to offer are those that have made a career of flying them, or perhaps a corporate president with a corporate budget to pay for it. No one in the helicopter industry has ever designed a helicopter for the private individual, a helicopter with the safety features, styling, dependability, and performance that the private individual would demand. And most important, a helicopter that you could actually afford to buy and maintain. It's a fact. Helicopters have always been out of reach for the private individual. Until now. The RotorWay Exec, the only helicopter designed and conceived for the private individual as personal transportation. It seats two. It cruises at 95 miles per hour with a maximum airspeed of 115. Its range, 200 miles. Its power plant, the RW152. Water-cooled, 4-stroke, 4-cylinder, 152 horsepower. Produced entirely by RotorWay. With asymmetrical airfoil rotor blades and state-of-the-art elastomeric rotor hub technology, it's a ship that rivals any in its class at a fraction of the cost. It's something you've got to experience for yourself. Sure, it's pretty, but how well does it fly? Well, man finally did it. The elusive dream of vertical flight is now a reality, and RotorWay Aircraft has done something almost as remarkable. RotorWay has made helicopter ownership affordable. But it wasn't easy. The evolutionary path to the present-day Exec was a very hard and long journey. In the beginning, 7 different prototypes were tested, but only 3 ever saw production. During the first 10 years of development, not one piece of hardware was sold. Finally, in 1967, the first magazine ads appeared announcing the availability of the Javelin, a one-man helicopter that could be assembled in a reasonable length of time by a home builder. To make a long story short, RotorWay never stopped growing or improving its designs, from the Javelin to the Scorpion, powered by a 2-cycle, 4-cylinder, inline Mercury outboard engine. The Scorpion 2, RotorWay's first 2-seat helicopter, utilizing a 125-horsepower Evinrude V4 for its power plant. The Scorpion 133. From the beginning, 10 different power plants were tested in RotorWay prototypes. Then, in 1975, RotorWay began production of its own power plant, the first generation of the RW133. And finally, on to the Exec, RotorWay's latest offering. The Exec isn't just a new face and an old design. It's powered by yet another engine development, the 5th generation of improvements, the RW152. Increased from 133 to 162 cubic inches, along with improvements on cranks, rods, cases, cylinder heads, water jackets, and pistons, just to name a few. There's a new ignition system and rotor system, and most obvious, a clean corporate aerodynamic design. The Exec is the world's only helicopter designed to be personally affordable, with a full-circle program designed to keep it that way. We'll get back to the Exec and more flying, but now we'd like to show you how RotorWay can offer a real helicopter at such an unreal price. This is the RotorWay manufacturing facility in Phoenix, Arizona. It's here that RotorWay Aircraft manufactures over 95% of the helicopter's components itself. When a company has reached the point where it can actually supply itself with everything it needs to produce its product, it becomes what is known as vertically integrated, a goal that almost every manufacturer of any product strives for, but very few ever reach. Being vertically integrated in itself is the reason RotorWay has broken the barrier of the high cost of helicopter production, and because of this, can offer a helicopter that is quite simply personally affordable. A quick tour of the RotorWay facilities will show you how it's done. First, we'll look in on RotorWay Foundries. The foundry does significant business with other aerospace and electronic firms casting non-ferrous parts for Garrett, Sikorsky, Hughes, Lear, Motorola, and numerous others. The same type of quality control that goes into the castings for these aerospace companies is used on the Exec helicopters as well. Here we see a crankcase for the RW152, the Exec's power plant, being made. First, the pattern is filled with sand from the overhead hopper. It's rammed tight against the mold, then separated from the mold with a pneumatic vibrator. Now the mold is ready to be poured off. Aluminum is melted down in the electric induction furnace. When the metal, in this case aluminum, has reached 1100 degrees, it's ready to be poured into the mold. Once the mold and metal have cooled, it's shaken out. Gates and risers are cut off, and then the castings are hand-tooled on belt sanders or hand grinders to achieve the final detail necessary. The rest of the shops you'll see in RotorWay's complex handle only RotorWay's parts alone. The next step on our tour is the machine shop. This is where most of the parts for the RW152 power plant and most other helicopter components are manufactured. Here in the grinding area, work is performed on the crankshafts. There are a total of 6 grinders in this area, and these machines can hold tolerances into millionths of an inch. In the secondary machining area are lathes, mills, honing, and line boring machines. Here, oil passages are drilled into crankshafts and machining is done on the main rotor hub plates along with several other operations. The numerical control area employs the standard advanced machining technology in use today by most aerospace machine shops. The tape lathe handles the shop's heavy turning operations with extreme accuracy and speed. The Spindle Wizard tape mill, with a 24-position tool changer capability, enables such operations as mirror image machining on the crankcases, along with several other advanced machining processes. The UltraPath tool programming for both the tape lathes and mill is done by an operator at a separate computer-assisted design terminal that you see here. Quality control is the single most important role with any aerospace manufacturer. In the 18 years that RotorWay's been producing aircraft, the philosophy has been to produce a quality product. The key to RotorWay's success lies in the quality control which is exercised throughout the product's fabrication. Employing some of the most recent inspection equipment on the market to date, the inspection area checks each and every part manufactured on the latest state-of-the-art 3-axis computer-controlled measuring equipment. The engine shop is where the RW152 power plants are assembled by hand. The castings and parts you'll see assembled here were poured at the foundry, machined in the machine shop, and have passed through dozens of quality control tests. Now, let's take a very fast look at the Exec's power plant, the RW152, being assembled. If you can work this fast, there'll always be a place for you here at RotorWay. After final assembly is completed on the RW152, an operational test is performed on every engine. This test involves using a specially designed dyno test cell, which can simulate actual load conditions which will be experienced by the engine during normal operation when placed in the Exec helicopter. Once placed in the dyno test cell, the engine is started and run up for the first time. Close attention is directed toward achieving proper engine torque, horsepower, and temperature stabilization. RotorWay also adjusts the carburetors, sets the timing, and calibrates the fuel flow. When you receive your engine, you and RotorWay know it meets all specifications. By going the extra mile required to put out an engine that has been tested and blueprinted, RotorWay is able to ensure high quality and reliability of operation. The next area we'll look into is the steel fabrication shop. This is where the airframes for the RotorWay helicopters are made. There are a number of operations being performed here, including the cutting, coping, bending, and scribing of the airframe tubing prior to being placed into the airframe jigs for welding. A jig is used to ensure precise alignment of tubing on all airframes prior to welding. RotorWay uses only the finest grade 4130 chromoly steel for its airframes. It's used because of its high strength, low weight characteristics. An oxygen acetylene torch with filler rod is used to weld the tubing together. You can now begin to see the Exec's roll cage design, which adds a great degree of structural integrity to the ship. After each piece of tubing has been tacked or welded into place, the alignment is double-checked, and then the frame is ready for shipment. The next area we'll look at is the fiberglass shop. RotorWay's fiberglass shop, just like all the other shops, is totally self-contained. RotorWay starts by building its own plugs and molds for the parts that are being made. The fiberglass process starts with spraying gel coat into the wax surface of the mold. The hand layup process is used exclusively for RotorWay products since they must be as light and as strong as possible for aircraft application. First, a layer of mat and cloth is pre-cut to a special pre-sized template. Then it's saturated with resin. The saturated mat is then laid directly into the mold. RotorWay utilizes the squeegee method, whereas the mat and cloth are squeegeed out by hand. Using the squeegee process removes the maximum amount of resin from the parts, making it as light as possible, yet assures the saturation of the material, ensuring maximum strength. The part is trimmed and after cutting is then removed from the mold. The RotorWay Exec is certificated by the Federal Aviation Administration under the amateur built category as experimental. What this means is that the ship is assembled by you, the owner. The builder applies for his own airworthiness certificate upon completion of his aircraft. This is a very simple, straightforward process. Now, if you're not familiar with custom or amateur-built aircraft, at first glance you may be tempted to dismiss the idea of building your own helicopter. Don't be in a rush to reject this unique approach. There are several reasons why this approach to aircraft ownership makes good common sense. First, if we were to sell this helicopter assembled, it would cost between $80,000 and $90,000. Well over 3 times what RotorWay presently sells it for in kit form. It'll take approximately 1 year part-time, that's evenings and some weekends, to build. But you'll be saving yourself around $60,000 by doing it yourself. Now, how many people have a $60,000 a year part-time job? If you build it yourself, you are allowed to do the maintenance, saving you even more money. Certified A&P mechanics cost $35 to $40 an hour. Now, if you own a factory-assembled aircraft, you'll have to pay a mechanic to inspect and work on it for you. The Experimental Aircraft Association fly-in at Oshkosh, Wisconsin every year is a testament to the dramatic growth of the amateur-built category. Attendance records are broken every year as thousands of people converge on Whitman Field to see the new and innovative designs emerging annually in the amateur-built category. There are presently over 100 aircraft kits on the market today. Thousands of people just like you are realizing every year that this really is the only way they can afford to own an aircraft. Now, these aircraft are affordable to buy and maintain, and they are more fuel and aerodynamically efficient than anything you can buy commercially at a fraction of the cost. So much for the practical aspect of building your own aircraft. Perhaps the greatest reason of all for building your own helicopter is the sense of accomplishment a person feels when he's flying the machine that he built. It's a feeling unparalleled by any other hobby or project. It's something you've just got to experience for yourself. And on top of all this, the project is an investment with appreciating value as you complete your aircraft. Once you understand the amateur-built category, you'll begin to see just how practical it really is. Now we'd like to show you a few of the hundreds of RotorWay builders and their ships. question you may be asking yourself now is just how hard is this helicopter to build? Now, we don't want to mislead you. We do prefer our builders to have some sort of a mechanical background. However, you don't have to be a mechanical genius to put one together either. RotorWay has left no stone unturned in its efforts to assist its builders. The RotorWay construction plans are some of the most well laid out plans in the home-built market. They include a series of 500 see-do pictures. Each photo has a caption below which gives instructions concerning the activity to be performed in that particular photo. In addition, if any dimensions are needed, you're referred to a zone on a print which will give those dimensions. In addition to the detailed construction plans, RotorWay also has a customer service department. If you have a question during the building process, you can call the factory and talk to one of our customer service representatives. RotorWay also has an extensive network of agents and builder clubs that can help you with questions and provide helpful hints and building techniques that will save you hours of building time. RotorWay assembles a lot of the more difficult components, such as the engine, secondary drive, tail rotor assembly, and elastomeric rotor hub. In short, a great deal of the more complicated components are already completed for you. Now let's take a quick look at a ship being final assembled. What you'll be seeing is final assembly. There is additional prefabrication work that must be done prior to final assembling your helicopter. When your ship is completed, you still won't be quite ready to fly. There will be a lot of pre-flight checks, rigging, and adjustments to make on the rotor system and flight controls. After these final adjustments are made, you'll be ready to run up your helicopter for the first time. And that day will finally arrive when you're ready to climb out in your helicopter. Once your ship is completed, you'll return to the RotorWay Sky Center for your flight training. After your orientation meeting, you'll begin a concentrated week of instruction. You'll learn helicopter aerodynamics, theory, maintenance, rigging, and of course begin basic hovering techniques. Flying a helicopter isn't as easy as it looks. It takes a lot of practice just to do the simple maneuvers you'll see here. To give you a basic understanding of how a helicopter flies, we'll have one of the Sky Center personnel explain the controls, how they work, and what effect they have on the ship in flight.
There are 4 basic controls in the helicopter: the cyclic, the collective, the throttle, and the anti-torque pedals. The cyclic controls the tilt of the main rotor disc. As you increase cyclic forward, you tilt the disc forward. As you bring cyclic aft or rearwards, you tilt the disc to the aft. When you tilt the disc to the left, you apply left cyclic. To tilt the disc to the right, you apply right cyclic. Let's take a moment and look at the flight controls up on our rotor system. Forward cyclic tilts the swash plate forward. Aft cyclic tilts the swash plate to the aft. Lateral to the left and lateral to the right. Now we come back to a centered cyclic. Our next control is the collective. The collective controls the pitch in the main rotor blade and is used to increase or decrease the amount of thrust coming out of the main rotor system. As we increase collective, we increase the pitch in the blades. As we decrease collective, we decrease the pitch in the blades. Let's now look at how the collective functions on the main rotor hub. As we increase pitch, the swash plate moves up, increasing pitch in the blades. As we decrease pitch, the swash plate moves down, decreasing the pitch in the main rotor blades. Our next control is the throttle, which is located on the end of the collective. It is normally operated with the left hand, and to increase throttle, you simply roll the throttle on. To decrease throttle, you roll the throttle off. Throttle is required when you increase and decrease the collective pitch in the main rotor system. The controls of the throttle are connected to the carburetor and increase and decrease the throttle opening on the carburetor. Our last control is the anti-torque or tail rotor control pedals. These pedals are used to control the heading of the aircraft and to resist the torque that's put into the main rotor system from the engine. As you increase right pedal on our aircraft, we increase the pitch in the tail rotor blades. As we decrease the right pedal or increase the left pedal, we decrease the pitch to neutral and then actually add pitch in the other direction. As we bring the pedals back to the neutral position, now let's look at the tail rotor and see the reaction there. First, starting with a neutral pedal, we will increase pitch in the tail rotor blades with full right pedal. At full right pedal, now we will come back in with full left pedal, and you can actually see the reverse angle on the blades. Now we'll come back again to our neutral position. Now, as I move the helicopter controls, we'll have a demonstration of their effect on a flying helicopter. Now let's watch a helicopter in flight as I move the controls in the same relationship in this split-screen demonstration. As we come to the point where we're ready to lift off, we begin by increasing collective until we come up into a hover. Coming up into the hover, find that we're in a stabilized hover. Now forward cyclic to move from one pad to the other. Forward cyclic is reduced a little bit to neutral, and then aft to stop the movement. Now we come aft some more to actually back up from one pad to the other. Neutral, slight forward cyclic to stop the motion, and come back again to a neutral cyclic and a stable hover. Now we perform a left hovering turn by increasing pedal to the left. Now right cyclic and right pedal so that we hover sideways to the right, back to a neutral position with both controls, stable hover, and now left cyclic and left pedal for flight to the left. Coming across, we begin to neutralize our controls so that we slow down and come back into a stationary hover. Now we perform a 450-degree turn to the left, staying in a stable hover, and now lowering the collective to sit back down onto the ground.
When evaluating any aircraft, in addition to price and performance, the question of reliability also comes up. The Exec has established a high level of reliability, and there are several reasons why. The airframe employs a roll cage design that protects the passenger compartment. Then, in order to reduce the risk of post-crash fire, the Exec uses a special high-impact resistant fuel tank material produced by Phillips Petroleum. These tanks are rotationally molded from a cross-linked high-density polyethylene resin. It's far superior to metal for several reasons, but primarily because of impact strength. Using the Exec's external sling, we'll demonstrate the strength of the fuel cell. First, we fill the tank with gasoline and then attach it to the sling. Now we'll take it to an altitude of 30 feet for the drop test. As you can see, the fuel tank easily survives the impact. When you consider the fact that post-crash fire danger is a major cause of fatalities in aircraft accidents, having a fuel tank that resists punctures and impact breakage better than metal is a major safety feature. One of the most commonly asked questions concerning helicopters is what happens when you're in flight and the engine quits. First of all, you need to realize that it's not the engine that's keeping the helicopter in the air, it's the rotor blades. If you're driving your car down the road at 55 miles per hour and the engine quits, you'll coast for a while, then come to a gradual stop. The reason is because of the inertia the car has built up. The inertia of forward speed keeps the car moving. Now, the same thing happens with the helicopter's rotor blades. They will keep turning after the engine quits and gets you safely to the ground while freewheeling. This maneuver is called auto-rotation. Let's take a quick look at the auto-rotation maneuver. The helicopter is a totally unique aircraft in that it can land without power at 0 forward speed and 0 descent rate if the pilot controls the machine properly. In auto-rotation, the helicopter will of course begin to descend. A forward speed of 50 to 65 miles per hour is maintained. Auto-rotational sink rates vary around 1,200 feet per minute depending upon the disc loading of the helicopter. The angle of descent varies from as high as 60 degrees down to as low as 35 degrees. Here you see the angle of descent for the Exec, which is a very good descent angle as compared to most other helicopters. An auto-rotation maneuver is composed of 3 phases. First, the entry. Going into auto-rotation, the pilot immediately lowers the collective pitch. This allows the airflow, which has been caused to flow downward from above the rotor disc to below the rotor disc because of the torque on the main rotor shaft, to reverse and flow up through the rotor disc. This upward flow of air imparts a rotational velocity to the rotor system, which turns the blades in the same direction and at the same RPM at which they were turning when they were under power. Second, the steady state portion. In this portion of the maneuver, the helicopter is descending toward the ground while the pilot maintains his forward speed. Third, the recovery portion. In this portion of the maneuver, the pilot flares the aircraft, thereby braking both his forward speed and his descent rate to 0. During the flare, a greater amount of air is entrained into the rotor system, causing it to speed up by approximately 10%. At the end of the flare, just prior to the tail rotor of the helicopter getting too close to the ground, the pilot levels the aircraft. At this point in time, the aircraft will be moving forward approximately 5 miles per hour. As it descends the last 3 feet to the ground, the pilot pulls back up on the collective stick, using up the inertia stored in the rotor system to cushion himself to a soft touchdown. The auto-rotation maneuver, if performed properly, provides for unusual safety in the event of power loss. Any knowledgeable pilot knows that an emergency landing in an airplane must be made just at or above its stall speed in order to avert a total disaster. Landing at 50 to 60 miles per hour on an unprepared surface can be hazardous, but as can readily be seen, landing the helicopter at 5 miles per hour or less with a very low vertical rate of descent is a much safer method of approaching the ground. Where would you rather be in an emergency landing? On an unprepared surface at 50 to 60 miles per hour, or landing a helicopter at 5 miles per hour? The Exec is one of the best auto-rotating helicopters in the piston-powered category. The reason for its impressive auto-rotational performance is because of its asymmetrical rotor blades. In fact, this helicopter is the only piston-powered machine on the market with asymmetrical rotors. They are only found on larger commercial ships. In the cross-section shown here, the top blade is of asymmetrical or unsymmetrical configuration. The bottom blade is symmetrical. The asymmetrical blade on top resembles an airplane wing, so in essence you have a rotating wing that creates lift at 0 degrees pitch. With the symmetrical blade, you create lift by increasing the angle of attack to relative wind. So you can see why the RotorWay asymmetrical blades create high lift more easily. This makes a drastic improvement in power-off auto rotation. Igor Sikorsky, the father of the helicopter, dreamed that someday his unique machine would be man's servant of peace, a dependable workhorse and effective rescue vehicle. His dream has come true. The helicopter has a multitude of uses, and the Exec is no exception. With the addition of the new RotorWay flotation system, the Exec can land practically anywhere. Water flying opens scores of new landing sites and offers pilots an exciting new way to use their helicopters. You can just imagine all the places you could be going, camping and fishing on secluded lakes and rivers, places where very few have ever been. Floats make the inaccessible accessible. On the farm, the Exec is a proven workhorse. When equipped with the RotorWay ultra-low volume agricultural spray system, applying chemicals to a small or mid-sized operation becomes very cost-effective. A typical maximum load of chemical will cover 160 acres in 1 hour and 20 minutes. In minutes, the spray system can be easily removed to free the operator for other chores such as checking crop conditions and irrigation systems, and the list goes on and on. On the ranch, the Exec makes the pickup as well as the horse obsolete. Rounding up livestock, locating strays, and checking miles of fence are done in minutes instead of hours or even days. Since the Exec runs on unleaded auto fuel and not expensive aviation fuel, you won't have to fuel up at busy airports. Now, we don't suggest landing in a crowded downtown gas station by any means. However, if the location and situation are right, you may be able to land close to a gas station, fill up, and be on your way in no time. Speaking of time, the helicopter really is a time saver. The Exec cruises comfortably at 95 miles per hour and burns only 8 gallons of unleaded fuel per hour doing it. No traffic, no red lights, and no speeding tickets. Just quiet, direct transportation from point A to point B in a fraction of the time at a fraction of the cost. You've seen how affordable and practical the Exec is, but do you really want to know what the best thing about the Exec is? It's just plain fun. You've just got to experience it for yourself. The RotorWay Exec, the helicopter you probably can afford. A helicopter you definitely have to experience for yourself. A helicopter built from one of the most comprehensive kits on the market. Every last nut, bolt, and even some specialty tools are supplied with the kit. Don't forget, with the Exec, you're not just buying a helicopter. You'll learn everything about helicopters, from the mechanics of machine to the theory and aerodynamics of flight. It's a constructive use of your spare time, an investment with appreciating value, a sport, a rewarding hobby, not to mention an unbeatable business advantage. Now, there is no way you can evaluate this helicopter from this videotape alone. Now, you've got questions. Can I afford it? Can I build it? Can I fly it? Is it the right time for a project like this? Once you've answered these questions, then and only then can you make a qualified decision. We're here to assist you with that decision. You've already taken the first step. The second step is acquiring all the information you can. We urge you to call with all your questions. The third step is a visit to our manufacturing facilities in Phoenix, Arizona. Qualify RotorWay as a company. Tour the complex, an education in itself. Meet the people behind the Exec, people truly dedicated to affordable flying. Then, evaluate the Exec for yourself with a demonstration flight. See, touch, and fly this helicopter for yourself. Maybe this helicopter isn't for you, but you'll never know if you don't experience it for yourself. Don't deny yourself a truly great learning experience, sport, and hobby. Call the factory today so we can set aside some time just for you. We'll provide you with a day of education and excitement you'll never forget. The thrill is back. Call RotorWay today.